So this will be followed by Dr. Tetsuji Yasuda, Director General, Department of Electronics and Manufacturing, AIST. We'll talk about the development of advanced semiconductor manufacturing technology at AIST. Yasuda-san, please. So I am Yasuda from AIST. So I hope you can see the screen. So the advanced semiconductor manufacturing technology development at AIST will be my topic. As Mr. Nishimura just explained, among NEDO post-5G projects, AIST is involved in these three projects. First is the development of manufacturing process technology and pilot line for advanced logic devices with 3D channel structures. And we call this front-end project. And we participants are Tokyo Electron Screen Semiconductor Solutions and Canon. And we will be working on nanosheet transistor. So this is a pilot line to produce nanosheet transistors. And second is 3D IC technology research and development. We call this back-end projects. And participant is TCSMC Japan 3D IC R&D Center Incorporated. And there's another back-end project, development of direct bonding 3D stack technology with RAS, Research Association for Advanced Systems. And Professor Niwa will be introducing this later in the panel. And where this project will take place, this is the picture of AIST Tsukuba West. We have a super clean room building and SCR building, and we will have the front-end project in the super clean room SCR, and the back-end project will be in the high-functional IoT device research building, and the construction of the building has already been completed, and now we are preparing the facilities inside the building. So about the front-end projects, the background. In Japan, there is no semiconductor fab producing advanced logic IC, but as you know, equipment and material companies are very competitive in the world market. On the other hand, from 2024 to 2025, the 2 nanometer, sub 2 nanometer will come into the market, and the transistors will change from FinFET to nanosheet FET. So a big paradigm shift is coming, and the nanosheet FET is very complex. So this is very difficult for one company to develop and validate. So the purpose of this project is for AIST to offer a common pilot line to fabricate nanosheet FET, while TL Screen and Canon each develop future technology nodes. So that is the purpose. And in SCR AIST, there is a 65 nanometer CMOS line up and running, and we will add 20 new machines so that nanosheet FET fabrication can be done. This pilot line, other than these three companies, many companies and universities will be able to participate, and we have started a consortium. Tokyo Electronic will provide new equipment and material. Screen Semiconductor Solutions will offer cleaning and annealing technologies. Canon, nanoprint lithography technology, and they will develop that in their own sites. And the wafer will be exchanged with AIST line. And each company's product can be validated in the AIST common pilot line. The technologies to be developed in front-end projects, there are 4 of them. First is lithography, argon F immersion lithography, and pattern formation by nano-imprint lithography, and direct writing by electron beam lithography. So this will be an alternative to UV disclosure. And silicon nanosheet formation, silicon germanium epitaxial growth with low defect density, low damage etching of heterostructure, and selective etching of silicon germanium. And number 3 is high-K metal gate stack formation. In the nanosheet, there are very small nanospaces. So we will have gate all-around formation of high K metal gate stacked by ALD. And number 4 is the integration of these 4-element technologies to have nanosheet transistor process integration with low power consumption and noise. The pilot line will be open to a wide range of users. And the activities is to facilitate R&D and implementation of advanced semiconductor manufacturing technology through pilot line. And we have established a consortium. And this consortium, the members will be able to efficiently do the development when they need the facilities. And there are 3 types of members. Category 1 are the 3 companies who will be participating in building the line. And category 2 members are the users of the line. And category 2 members are able to join after next year. So namely equipment manufacturers, materials manufacturers, and device companies. And support members will cooperate in terms of information exchange for line building. There's TSMC, Intel, USJC, TPSCo, and IBM. And Mr. Tateiwa from TPSCo will be participating in the later panel discussion. And benefits or advantages of becoming a consortium member. By becoming a category member, you can use the latest equipment installed in the pilot line, as well as common IPs developed in front-end projects. And like the category 1 members, they can validate in the full process and each member can perform R&D of its own interests under joint research agreements with AIST. Therefore, the joint research secrets will not leak to other members. And also, there are seminars and workshops which are limited to consortium members. So if you are interested, please contact the email address shown on the bottom left. And this is a schedule of setting up the line. And we are now going through a government procurement process. And in February or March, we will be able to show the information on the web page, and then the equipment will be installed and be enabled, and this will be available to the users middle of 2023. And a nanosheet FET full process will be available in 2025. So it takes quite a time until the full process becomes available, but there are already equipment. There is AIST system where to perform R&D in AIST facilities, and that is available already. So please look at these websites for further information. So what is related to what I have spoken up till now, the AIST started the activities of the next generation computing platform development base, and we started this year. So this is, for example, quantum computing and optical computing. So this is the next generation computing, and the functions include R&D strategy, R&D execution, and open innovation platform. And the front-end pilot line will be a poster child of this open innovation platform. And next is about back-end projects. I will explain briefly. Participant is TSMC Japan 3D IC R&D Center, and the R&D line is the AIST Tsukuba West, which I showed you the photo earlier. And AIST assignment is taking part in the development of new materials and processing technologies for 3D IC packaging. And we have the chip on wafer on substrate structure. And we show the roles and responsibilities sharing between AIST and TSMC. AIST will be responsible for thermal interface materials, micro bump, and mounting assembly will be done by TSMC. And for further details, there will be a keynote speech by Semicon Japan from Mr. Chris Chan, who is the director of TSMC Japan 3D IC R&D Center. So this is a summary. Front-end and back-end lines for cutting-edge semiconductor manufacturing R&D are to be set up in AIST Tsukuba. And AIST is pleased to host this open innovation platform for a wide range of players of industry, academia, and government, as well as for international cooperation with overseas R&D organization. So that was all from me. Thank you very much.